In this video, we're going to talk about the metric system, which is so much easier to use than our conventional ways of measuring things like mass, length, and volume. We use the same set of prefixes no matter what measurement we're describing, as opposed to a different set of conversions depending on what we're measuring. For example, in the US, if we're measuring length, we could use 12 inches in a foot, or there's 5,280 feet in a mile. Not easy numbers to work with. However, in the metric system, everything's based off of units of 10. And again, it's the same set of prefixes regardless of what you're describing. So those base measurements, we use meters to measure something like length, we use liters to measure volume, and we use grams to measure mass. So let's start from there and then work our way out to things that are larger. And then after that, we'll work our way through things that are smaller than those base units. So if we have 10 base units, okay, we would call that a deca either meter or a decaliter or a decagram, and that would represent 10 of those base units. If we had more than that, so say we're describing something a little bit larger, we would use something like hecto. Hecto represents 100, so you have 100 meters, you have 100 liters, you have 100 grams in either a hectoliter, hectoliter, or a hectogram. It's also where we get the term hectare, which is 100 square meters. Then if we're going on the order of thousands, so something larger, like if you were measuring the mass of a person, you would use kilograms, you wouldn't want to use grams, and each kilogram represents 1,000 grams. And then once we get to 1,000, then we work off each increment increase is by an order of 1,000. So going from kilo to mega, a mega meter is 1,000 kilometers. It's also 1,000,000 meters. And then giga is for really large things on the order of the billion scale. So 1 gigameter is 1,000,000,000 meters. Also, you know the term giga because when you're talking about storage on your phones or processing speeds, we usually use things like kilobytes, megabytes, gigabytes. So those are all orders of 1,000 changing in increments. Then going small. And notice, you're always going to have more of the base unit than what we're describing as the prefix for the things that are larger than the base. So make sure when you're setting up a conversion factor that if you're talking about things larger than the base unit, you put the big number with the base unit, either meter, liter, or gram. Now, if we're talking about things that are smaller, you're always going to have more of whatever that prefix led term is than you will base unit. So in 1 meter, there are 10 decimeters. So if you took this and broke it into 10 pieces, each section would be a decimeter. If you were talking about on the 100 scale, so there are 100 centimeters in a meter. Going even smaller than that, if you broke this up into 1,000 pieces, you have millimeters. And then again, going by order of 1,000s after that, you have micrometers, which is 10 to the 6th, and then you have nanometers, which is for really, really small things. You have 1,000,000,000 nanometers in a meter. You're talking about the scale of atoms at that point. So the symbols that we use to represent these, for giga, we use the capital G. For mega, we use a capital M, kilo K, hecto H. Deca, we use DA. Just be careful you don't confuse that with deci, which is just D. Then you have centi with a C, milli with an M, and then we use mu, which is a Greek symbol to represent micro. If you are typing it, just use like a lowercase u and that'll be fine. And then N for nano. So now I'm going to show you how you can use these conversion factors to convert from one term to another. So say we had 5.8 megameters and I asked you how many meters that is. I want you to use dimensional analysis to set this up in order to solve the problem. Use the relationship you know. And again, when you're doing dimensional analysis, always put the unit that you have on the bottom and put what you're looking to go to on the top. And I can directly relate meters and megameters, and I can say that I have 1,000,000 meters in 1 megameter. I'm going to point out that these do not impact sig figs as these are absolute relationships. So the answer to this would be 5.8 times 10 to the 6th meters is equivalent to 5.8 megameters. Now, that's when you're going directly to a base unit, or if you're going from the base unit to something else, you can do it in one step. If we're going between two things that don't include the base unit, I like to do it in 2 steps, where the first step is to go to the base unit. So in this one, I ask you, you have 2.85 hectograms. How many micrograms is that? Well, I can relate hectograms to grams, okay? And when I do that, again, hecto is bigger, so we're always going to have more of the base unit. We have 100 grams, or 10 to the second grams, in 1 hectogram. At that point, that would cancel out. I would be describing it in grams. And then I can relate grams to micrograms. Okay? And again, when we're talking about things smaller than the base unit, you're always going to have more of the one with the prefix. So in this case, you're going to have 10 to the 6th micrograms in 1 gram. So when we're doing this out, you would say that you have 2.85 times 10 to the, whenever you're multiplying powers of 10, you add the exponents. So 2 plus 6 gives you 8, and our units would be in micrograms. Okay? So hopefully that helps you understand how to use metric conversions. Have yourselves a great day.